big, long, ugly. But we know it boils down to a couple of things. The slope of the treatment group after the treatment is beta 1 plus beta 3 plus beta 5 plus beta 7, which are all basically the coefficients of time. And the intercept is beta 0 plus beta 2 plus beta 4 plus beta 6. All right. Compare the before and after for the treatment group. In other words, here's the slope of the treatment group before, which is beta 1 plus beta 5, right? So here's the slope of the treatment group before, beta 1 plus beta 5. Here's the slope of the treatment group after the treatment, and it's that big long beta 1, 3, 5, and 7. If there is a difference in this slope, beta 1 plus beta 5, and this slope, beta 1 plus beta 3 plus beta 5 plus beta 7, then what should be different? So if you just subtracted those two, what are left over? Beta 3 and beta 7. Exactly. Is the difference in the slope of the treatment group after the treatment. So beta 3 plus beta 7 represents the change in the growth rate in the treatment group after the treatment. And again, we can see that mathematically. We took this slope, beta 1 plus beta 5, took the difference with that slope, we're left with beta 3 and beta 7. Now, if beta 3 and beta 7 are essentially 0, then there was no change in the treatment group after the treatment. You gotta be really careful with your language. Which would mean what? If beta 3 and beta 7 were both 0, then this line would just go on and there'd be no change in the treatment group after the treatment. Right? Man, it all makes sense when you look at it on a graph. The trick is looking at the coefficients.
All right, just to go back and make sure. So when we're looking at the analogy here of control and treatment, the control is just another varietal of wine other than Merlot, and the treatment would be being Merlot.
Correct.
Okay.
But again, we said this has wide marketing applications and drug applications. All right, that's the control group. We want to do the same thing. What's the difference in the growth rate after the treatment for the control group? The difference in the growth rate for the control group after the treatment. What's the difference between this slope and that slope? Beta 3. The change in the time trend for the control group after the treatment is beta 3. just did this one, we know that the change in the growth rate after the treatment for the treatment group is beta 3 plus beta 7. That's what we just finished doing. Beta 3 plus beta 7. What we want to know is, did the treatment group change by more than the control group after the event? Did the treatment group change by more than the control group after the event? Does that make sense? So we're not going to compare slopes. We're not going to compare this slope and that slope. We're going to compare what? The change in slopes. Because we want to see if the treatment resulted in differential changes. That's what we want to look at. So if beta 3 plus beta 7 represents the change in the treatment group after the treatment, and beta 3 represents the change in the control group after the treatment, what's the difference of the changes? All of this boils down to one coefficient. If beta 7 is statistically significant, then, here comes an alpha. The treatment group changed by more than the control group after the event occurred. So we're not looking at the slopes, we're looking at the changes in the slopes after the event.
So it's just saying the event caused a statistically
Significant change.
significant change.
By looking at one coefficient. That one coefficient is beta 7.
What kind of change, not in growth, or?
It'll be a growth, yeah, it's growth rate. So beta 7 is a coefficient of time. So it'll be this, if it's significant, if beta 7 is significant, then it'll represent the difference in the growth rates, the difference in the growth rate of the treatment group after the treatment relative to the difference in growth rates of the control group after the treatment. And this allows for any outside factors like the economy, right? Because when we look at, if the economy affects both the same, then when we take the difference, that effect of the economy will cancel out.
When we say significant, that would be like.
Is it T-stat greater than 2?
Yeah, so then it would be more than 2 standard deviations away from the control group's range.
Something like that.
Outside of the 95%.
Something like that. You're complicated.
So if we're testing the Merlot versus a bunch of different varietals, we want to see that beta 7, that change in its growth bigger than whatever changes for the other varietals are testing against.
Yeah, either positive or negative. And in this case, I mean, look at it. It's, let's describe this case just verbally. The event in this case, let's say this is true, and all of our coefficients are statistically significant. So this would be a situation in which, let's say something caused an increase in the growth rate of the control group, of everyone else other than the treatment group. So in this case, the treatment is negative because it what? It slowed down the growth. It's kind of like with drugs. One of the problems with, I don't want to get into a political thing, but one of the problems with like these homeopathic drugs, cancer drugs and stuff like that, is that you take them instead of doing what? traditional medicine. So you end up not getting well as fast, right? So this would be something like, I'm gonna sniff this because someone told me it's gonna cure my cancer. And instead of doing traditional remedies, these people got well faster while you didn't. So maybe it had a small effect, but the effect was still different than the treatment, the control group. Because you can have all kinds of scenarios in which you get differential effects. That's why we're looking at the difference, again, this is a mouthful, the difference in the difference of growth rates, right? Beta 3 is the difference in growth rate for the control group before and after. Beta 1, 3, 5, and 7 is the difference in the growth rate for the treatment group before the treatment. So this is a difference, and beta 3 is a difference. We're looking at the difference of the differences, and that boils down to beta 7. So let's do a couple of that. And let's look at the growth rate of two trends. And kind of the traditional one would be, as we said, there's no change in this slope. And then we want to see if this growth rate, so this is our control group. And then we want to see if there's a change in the treatment group. Right? It could be positive, where some market event had a positive impact. Or it could be negative, where some movie had a negative impact. Right? Some commercials, some new ads. You thought of them, they seem like a really good idea. Everybody loves Jared. He's the Subway guy. Yeah, let's hire him to be our pitch man. Oops. Yeah. Who doesn't love Bill Cosby? He's the Huxtable dude guy. Yeah. Sometimes things happen. Do those negative events result in negative sales? There's only one way to find out. We'll see. Right? But this is the ideal circumstance, but most things aren't ideal. What if this fell, and this is the control group, and this fell?
As long as the treatment's falling is extremely sharper than the control group's falling, then you would say yes, something.
Exactly. As long as the difference in the slope here,
Yeah.
from
That
before
could-
and after,
that could be
is
your
greater than the
temperature.
difference in slope there.
Yeah. Could be your body temperature after taking some kind of a pill for the flu.
Yeah, exactly. So things don't always work out in that kind of perfect ideal where the control group is just perfect. It stays on the same trajectory.
So go on and maybe choosing to rise.
Yeah, exactly.
Do they also cross each other? For one going
Absolutely.
down
So
and
you
one
can
going
have,
up?
yeah, and so you can have, so here's the treatment group. And let's say that this is the control group. Oh, they're not crossing.
Yeah, one of the other. So the control group would go down, but the treatment group would go up.
Yeah. But these are the more difficult situations, right? Something like this, because it looks like the treatment group, there's clearly a change after than before. The problem is the control group grew even faster. So what was the effect of the treatment? It's a negative effect because why isn't it growing as fast as everyone else? Well, maybe because you should have had both Jared and Bill Cosby as your pitcher. And yeah, I mean, the kind of the easy one is while your control group is going down and your treatment group is going up. And whatever it is fantastic, because not only did it reverse a decline, it actually caused an increase. This model is general enough so it'll handle any circumstance. Any of those situations, we'll be able to figure it out using this one model. This one test, this test of whether or not some event had an effect. Yeah, and the beauty of this is it really boils down to, after all that work, look at that one coefficient, beta 7. That's something statistically different than 0, then we think that the treatment had some effect, either positive or negative. So beta 7 is the difference in the change of growth rates of the treatment group relative to the control group, relative to change in the control group after the treatment.
When you say a 2 p-value, you're giving it a 2. What if it's negative 2? That means it's
Absolute value.
the absolute value. Okay.
Yeah, if you have a negative coefficient, you'll have a negative t. All right, any questions before we, I think that's it for this. Nope, I gotta do that. All right, why that happens every time is even string. Resolution. Changes, no longer, no matter how many times I tell it to keep changes, it changes back. After all that big mess, we need to do what? Generate one variable. We need one new variable, and then all the rest are what? Our interactions. That's it. We're done. That hiccup? Drink it earlier? All right, so let's do it. So the one is relatively easy. We already tabbed varietal. And we know it has 3 values. Cabernet Sauvignon, Pinot Noir, and Merlot. Now in the paper I actually used a just talking about wine, people are, it's not a contact high, it's a, what do you call it? Psychosomatic high? Psychosomatic drunk. In the paper I used a group of varietals, Syrah, Cabernet, and I forgot what it was. The paper's been a couple of years now. For you guys, we're going to pick Cabernet Sauvignon. It's the biggest selling of the reds, and it really shouldn't have been effective. It was really not. It didn't play a part in the movie, you know, Merlot and Pinot Noir did. So we're gonna use Cabernet Sauvignon as a control group. Is it perfect? No. But it's easier than making a control group of a collection of wines. It's easier for you guys, it's not that big of a deal. All right, so what do we need? We need a treatment variable. Our treatment is Merlot, so we're gonna generate a Merlot variable. Generate Merlot equals 1 if what is true?
Right, or, yeah,
All right, you should have a new variable in here called Merlot. Let's have it. It's not quite a dummy, let's call it a stupid. A dummy takes on a value of 0, 1. I guess a stupid only takes on 1 value. We need to improve its IQ up to a dummy. We want it to take on a value of 0 when we're the, bless you. We want to take on a value of 1 when we're in the treatment group, Merlot, and 0 when we're in the control group. So 0 is going to be when, oh, I did that wrong, didn't I?
It's reversed, right?
Other way around.
Yeah, the other way around. I was thinking too much about Merlot. Actually thinking. All right, so we drop that. Drop Merlot. And I'm going to save that. This should be Merlot. All right. And I'm going to use this. I'm going to replace Merlot with a 0 if it's Cab. And I'm going to tab Merlot. And I'm going to tab Varietal. Why do I want to do that? Well, just to make sure the numbers match up. When Merlot equals 1, it should be equal to the number of observations that are Merlot. 7,800, 7,800 here. When Merlot equals 0, it should equal to our cabs, 89. So if I made a mistake, I would have cut it there. I would have reversed them and regenerate. So we constructed our variable correctly. We're done. The rest is multiplication. This times that, times this, times that, times that, times this. So we need, so what do we have so far? We got dummy verb for 2005. We've got our interaction for time in 2005.
Which is the interaction variable?
Excuse me?
Which is the interaction variable? I cannot see it.
You do not see it?
I can't see it.
It's the time times 2005. It's up there. We used it before for the first regression. So if it worked for the first regression, we'll assume it's still there and works for the second regression. So let's generate the rest of our variables. So we need a what? Generate, doesn't matter, the order doesn't matter. So let's call it Merlot time equals Merlot times time. We need a generate Merlot after what? Below.
That's time times after.
Yeah, our D 2005. And what are we missing? Low after time equals low times after times time. I got too many times there.
After, it's after you're there, right?
Excuse me?
After right there, is that really gonna, you don't have a variable called after.
Oh, it's not after, it's D 2000. Yeah. We're going up to power. And that's our after 2005. All right, I think we're done. Is that it? Hello? Hello, time.
And that's the treatment group.
Merlot is our treatment group. Merlot is the one we're trying to see if it was affected by the movie. Cabernet Sauvignon shouldn't have been affected by the movie. There was nothing bad said about it. There was nothing good said about it either. It was
Left alone.
pretty much left alone. So it should be unaffected by the treatment. Let's do this. Before we jump to that. Did I move it? All right, so there's our graph. These aren't regressions, this is just the same data we looked at before. And again, we see a flattening of Merlot after the movie, but we also see what? Kind of a slowdown in Cabernet Sauvignon after the movie too. Not as much, and we'll figure that out, but there's clearly a decrease in Cabernet Sauvignon after the movie. And it shouldn't have been affected. So if there were some economic effects, whatever was going on in 2005 or 6 or 7 or whatever, there was somewhat of a slowdown. If you just kind of hypothetically get that. This looks good, and this looks good. Why do that? Or these two look good? Because they look the same. If they look the same, it tells us before they were behaving relatively similar. And that's good because that verifies our control group. If we had two wines that were behaving radically different before, then that's a poor control group. Right? If we had one wine that was, let's just use this. Right? Well, I missed the cross, but let's assume, well, let's just leave it there. It's fine. Did the movie have any effect on anything? No. Did either of their trends change after the movie, after the event? No. Both of them followed the exact same trend. But if we were to look at, if we were to kind of just look at a graph starting from here, right? You could say what? The treatment had a great effect. But when you look at the graph starting from here, you say the treatment had no effect. Two polar opposite results resolved by simply looking at the trends instead of taking snapshots, or not giving it enough time before or after. comparing two completely different things. So the fact that these were behaving similarly before tells us that, yeah, our control group is probably pretty good. Is it perfect? No. I don't think there's ever a perfect control group, but we're probably pretty good. We should start passing around whatever you guys are drinking. That won't be like Woodstock. All right. Any questions? The one line I do remember from Woodstock was avoid the brown acid. The guy getting on the intercom saying, avoid the brown acid was a bad batch. As opposed to the other acid, which was a good batch. All right, we just want to run a regression now, so let's do that. Now in this, do we need to put the if statement now? No, because we want both Merlot and Cap. Did we have one with the down here? You run that first one? Yeah, there it is. There it is. So let's just start from here since we already know what we're going to get here, right? This is what we did in the last homework. Time, dummy for after 5, and then an interaction. We're going to add our treatment group, our treatment time, treatment after, treatment, 2 treatment times?
No, that was after time.
Merlot time, Merlot after.
That was Merlot after time, but you just put it on. You just put ER in instead of typing after.
Gotcha.
Merlot every time.
Shall we rename it or is that fine?
I'll let you put it in a,
What's that?
you got Merlot time, Merlot after.
Yeah, what are we missing here? Time,
Merlot
Merlot after time. Merlot, Merlot time, Merlot after, and Merlot after time.
Last varietal is after time.
All right, let me, I think I'm the one that's been drinking. This is Merlot
After.
time. Yeah. Who's what? Yeah. So rename that
Oh wow.
Merlot after time, since that's what it is. All right, so we got that. We got Merlot after, Merlot time. We have time after. Yeah. So I missed it.
You still need to add on the Merlot after time.
Yeah.
That was right.
Merlot time. Merlot after. And now, Merlot after time. Is that so? 7? Yes. Okay. So you outreg this, and we can calculate all of those growth rates. Let's try it. Let me see. Have this outragged already? What problem set would this be? 5.
You know, when I got my output, I got like a number plus EO, you know, it's showing all the
It's a
decimals.
big number, yeah.
How do I get rid of that?
For us, for now, it's fine. There is a way to go into outreg and have it increase the tolerance.
Is that just a parameter that's like a default thing? Like why?
It just means the number's really big and outreg is, stated is shrinking.
But is that, then that means my output was incorrect
No,
because
no, no.
you're not getting the same, like from the previous exercise, that's what I got.
From taking logs? From running the log regression?
Yeah.
Yeah, the log regression, the values shouldn't be that big. If you ran the
Probably
case,
just-
well, if you ran case volume, then you might have gotten.
Okay.
Okay, so let's try this. What is the growth rate? We got treatment and control group. What is the growth rate? Well, let's go back a second. So let's say before, after. Let's call this cab. Let's call this Merlot. And let's start with the one that zeroes out everything, which is not bad. What is the growth rate of Cabernet Sauvignon before the treatment? Hold on a second. Just get rid of all the superfluous stuff. What is the growth rate of Cab before the treatment?
0.067?
Correct. It's the coefficient on time. All right. What's the growth rate of Cab after the treatment?
0.162?
Or let's just say this, what's the difference in the growth rate of Cab after?
0.06 minus 0.03, right?
Yeah. So the growth rate will be beta 0 plus whatever we're calling this, which is beta 3.
Yeah, because it's positive, so you add, if it was negative, you would subtract.
If it was negative, it would be negative and you'd still add it.
Yeah, exactly. You would add.
Even though they're completely opposite statements. But you're right. You're exactly right. On one of them, we had a 50-50 chance. Okay, so those are the two growth rates before and after for CAP. Now let's go to the control group. What is the treatment group? What is the growth rate of Merlot before the event?
114.
Well, it's going to be the coefficient on time. It's before, so anything with 2005 is going to be zeroed out. Merlot's a dummy, so we need what? Merlot time? right? Anything with, after is gonna be a zero, because we're looking at the growth rate of Merlot before. Let's see, what is the growth rate of Merlot after? So it's gonna be that coefficient of time. And it's gonna be Merlot plus Merlot times growth rate before, plus time after, plus time after Merlot. We have time, Merlot time, time after Merlot. Percent. But this is what we got before, right? You got a growth rate of 8% and then 0, right? Yeah. So it's the same thing you got. But now we're saying, what's the difference? So let's do this. Oops. Let's go up here. I can't spell difference. Let's look at the change in growth rates after relative to before. So it's going to be this minus that. And it looks like, I'll figure what the graph said. It looks like the growth rate went up about 3%. Look at this, minus that, and it looks like the growth rate went down by that 8%. What did I just do? I took the difference of the difference in growth rates from before and after, right? And that tells us the difference in the growth rate of the treatment group after the treatment relative to the difference in the growth rate of the control group after the treatment. And we said that was which coefficient? Beta 7. Is that beta 7? Sort of? Sure, why not? So yes or no?
Yes.
If you say so. Well, where is beta 7?
Merlot,
It's the triple interaction. What is its value?
same.
The same. Coincidence? Could be. So what we have is actually something like this. It looks like Cab actually grew by a slightly small amount, 3%, and Merlot fell. So the difference is greater than just that 8%, because if you account for the fact that that Cab grew, then the difference is 11.3%. Scary. But when you see the problem set, they'll get scared. And leave it up, because it got to the work.
But now, is that difference of difference that
Yeah,
you look at, is that significant?
you tell me.
And visually it looks so, and numerically it looks so. Right now, it's bigger than zero.
Visually-
because of the numbers.
Visually and numeric, what is that? What do you mean by that? We just
Well,
eyeballing it?
when you
We have a
chart-
criteria for testing whether something's significant or not.
Your bracketed values say yes. 'Cause
Yeah, a
one-
graph visually would say yes, and then actually looking at those numbers.
No.
Now,
We have,
how
we
do
have,
you
we
find-
have, we have a criteria
how do
for
you calculate-
evaluating, we have a criteria for evaluating whether or not something's significant.
How do
We
you
spent
calculate-
20 minutes before talking about it. What is that criteria?
The T value?
Correct.
Well, where is that in the one that's missed?
Where has it been in all the other homework?
Somewhere.
Yeah, so we just need to find it, and that'll answer your question.
Where is it right here?
What is it?
On Stata, I see, under the T value, it's negative 50.49. So the absolute value, that's certainly bigger than 2, therefore, yes.
There you go. But we don't need to eyeball a graph or think that 11.2 sounds
That
significant.
information, oh, I see it right there, the double asterisk below.
And that's what those asterisks indicate. The asterisks indicate it's significant at a 5% level. Double asterisk means it's even more significant at a 1% level. So, remember those asterisks got in the way earlier?
Asterisk is really, really close.
Yeah, the asterisks got in the way earlier because I must have used outreg 1 for this, because outreg 1 puts them on the t-stats. I think outreg 2 puts them on the coefficients, is that right? We have to deal with that.
I just remember I took them out.
Yeah, we
because
had,
outreg-
yeah.
So
Yeah,
I
so
don't, I
We
don't
took
have
them
them
out
in
because,
mine.
yeah, we took them out because in outreg 2, it puts them on the coefficients, and once it puts it on the coefficients, we can't do this kind of stuff. We can't play with the numbers, because it'll read that asterisk as
String.
exactly a string, as a word of some sort.
It's a what?
A string. A word.
Instead of a number.
Instead of a number. Questions? Piece of cake? Yeah, see, outreg 1. Yeah, outreg 1 is